Hey guys, back working on the Merak 750. You know, it's been a while, but life gets in the way sometimes, and I had a couple other projects that I needed to get done before I got back to this. But here we are, we're getting started on steps 4.1 and 4.2, working on the rotor head and the swash assembly. To note, this is the stock rotor head. It's in one piece, real nice, high quality. I elected to go with the F3C center combined hub option, and that comes in 3 spots. You got this center hub and then the 2 outer hubs that are removable. Inside the center hub will be these 2 plastic bushings and the spherical ball with the cutout for the feathering shaft, and those will fit in there like that. So yeah, really nice piece, high quality, as I've mentioned before. The blade grips are already assembled at the factory with grease and everything, so there's no need to take it apart and look it over. For the pitch change links, or the tie rods as they're called here, I elected to go with the titanium alloy rods, and obviously these are turnbuckles, so you can get a real nice adjustment on there. Other than that, pretty much basic parts for the washout levers, and then the main Jesus bolt there, all the ball links and the rubber dampers. Obviously these are your arms for the blade grips, some hardware, and then obviously your feathering shaft bolts right there. A little bit of a stepped washer, and then these in there are some shims if required when assembling. He provides those. There's a note in the instructions about that, and obviously part of the washout arm setup. So next step for me will be to get all the hardware out and get it into the ultrasonic, get it cleaned up, and we will move on to the next step. Okay, so this is all the parts laid out for steps 4.1 and 4.2. We have obviously the swash, the blade grips, and then the rotor head. This being this 3-piece rotor head, there's a few more parts involved, but nothing cosmic. These are 90 durometer dampers. And for the feathering shaft, the shims that are mentioned in the manual, you've got 2 different thicknesses. You've got a 0.1 millimeter and 0.2 millimeter. So I'll dry fit it all together first and try to see if there's any play without them, and then if I need them, obviously I'll start with the smallest one and work my way in. For me, when it comes to thread locking all these components, I typically use thread lock sparingly. I don't use a whole lot, but on 3 millimeters I do use a blue thread locker, even though that's considered too much. Blue thread locker really starts at about 6 millimeters and up. So I just use 243, which is got a little bit better resistance if there's oil and stuff on there. But for any bolt that's 2.5 millimeter or less, I use the purple thread locker, just 222, and that's worked out great for me. Haven't had anything back out or anything, especially on an electric helicopter and an F3C like this. That's super smooth. A lot of parts, but we'll get at it. The only thing to really talk about that I do, and might be something good. So these use 6 millimeter bolts in there, and these are the actual feathering shaft bolts. But I actually, when I'm getting ready and everything's all greased up to prevent grease from getting into the threads, I have this one bolt that's out of my bench stock, and I just kind of throw that in there, thread that all the way through, and then once I'm through both blade grips and everything, I will go ahead and then pull that out, and then that prevents me from having to come back later and clean that out after installing the piece. But yeah, other than that, pretty self-explanatory. Just got to make sure you're aware of orientation and stuff. But yeah, I will not show all the steps. I will just build it, and then I will tell you if I needed any shims or not in the build process. Oh, for lube, I am using just super lube. I've used it for a long time and it works good for me. So I'll be using that on the dampers, on these plastic bushings and that spherical, and then a little bit on the feathering shaft as well. So that's what I use. Other than that, we'll be back in a few minutes. Okay, 4.1 and 4.2 are complete. Nothing really to note. We'll start out with the swash. Swash went together really nice. I didn't mention in the previous clip that all the linkage balls on the swash are the same size, so that's nice. The rotor head did not require any shims, and it went together really, really nice. Super smooth rotor head, no play. If you feel anything, it's the slightest bit of what I would consider bearing tolerance, and then there's no gap between the spacer and the blade grip, so that's what they wanted. Obviously F3C, so I used the outer hole location on the arm. The washout, the optional 3mm set screw, I ended up not using it. I felt like this was super smooth the way it was. There's no play in it at all. But as this develops some wear and play over time, that set screw might become applicable at that point. But at this time, I'm not going to use the set screw. No Loctite on here for the washout arms until I get it installed onto the main shaft. So yeah, other than that, yeah, just a basic, you know, it goes together like almost most all rotor heads, just a really high quality rotor head. So yeah, real happy with that. Next will be the tail components, and I will get those out and we will get started on the next step. Okay, all the tail components are laid out on the bench. Get ready to get started here, working on the gearbox, the tail pitch control, and the tail rotor grips and such. A couple of items that I'm going to upgrade are the tail drive shaft. So the stock parts are right here. The shaft and the hub are in two separate pieces with all the components nicely labeled in the bag. I'm going to be using the new tail drive shaft set, and that has got the shaft and the hub integrated into one unit with the feathering shaft going through with some rubber O-rings. There. Here's the stock tail rotor grip. Real nice piece to note. These bearings are installed with green retaining compound already. And here is the new, I'll actually keep this side by side so you guys can look. And then here's the new tail grip. As you can see, the weight's kind of distributed down towards the root of the grip. And again, these are already installed with green retaining compound. A real nice, this should help with stability and performance in the tail. Other than that, for now, this locking collar is a stock one, and as you can see, it's just a collar and a ring. But I'm going to be using, for now, I'm going to use this piece because I'm going to install the vertical fin while I'm flying it in pod and boom configuration for testing. After that, then I will reinstall this clip as I get ready to install it into the Excellent fuselage. I've already completed the tail boom supports. That was done with these jigs that worked out really good to hold everything together and perpendicular and stuff. But I showed that on the RVE Heli Club Facebook group. I showed these already, and then there's a STL file that's located there if you guys wanted to use it. I showed more pictures on there in depth. That's all I've got to talk about now. It's just a matter of getting all the components out of the bags, placing them in the parts bin for organization, and then from there it will be cleaning all the bolts and getting ready to start the tail build. So we will be back momentarily. All right, we got all the parts laid out for the gearbox and tail pitch control. Not much to really talk about. I like to take all the parts, even if I'm not making a video, and kind of put them all out like this so I can kind of see orientation and get a better understanding of how it all goes together. Couple of things to really note here on the tail pitch control arm mount, which is this piece right here. It's hard to see, but this is so close you can see there's a little bit of a convergence towards the mount there, and then this one is just straight. But if you look real close, there's a little bit of a chamfer on this side, and this is the side that goes towards the head. So this would be facing forward. So just want to point that out. And another note, with this new integrated hub on the tail shaft, you're going to have to assemble the tail pitch control setup first, install that, and then you'll be able to put it in, because if you just put this in, assemble it like it says, like this, you would never be able to get on the rest of the parts. So you're going to have to assemble it in reverse order, kind of like this, with all the tail pitch control on that side before you get it all together. So I'll have to do some dry running just to make sure of the fit, make sure there's no shims needed. So when you put this these two pieces together, you got to shim it out to make sure that with the drive and everything that there's no play. But we'll work on that as we go. Yeah, nothing really to talk to. The only other thing that I do this for almost all my thrust bearings, and it's not really needed. I used to write it on a piece of paper just so I remember the small and the large. Obviously the large goes towards the root. But in my case, I make these posts the size of the smaller ID part of the thrust bearing and large ID, and it works out great. It allows me to go ahead and grease them up and everything, and then assemble it, and then I just wipe it off and clean it. But yeah, it works out good. It's not shown in the manual, but it was shown in on the website. In this is a stock tail shaft, but in here, if you look, there's a couple rubber O-rings, and they have those going against. Will be on this side against the bearing here. I don't know if those are needed. I might take that out and put that in, but we'll take a look as we go. I'm not gonna unless there's something really to note as I'm putting this together. I'm just gonna assemble it and then show it. I did get a tripod mount for my iPhone so I can film on a bench, because the helicopter is gonna start getting pretty big at this point. But yeah, we'll get started on all of it and show you what it looks like once it's complete. Okay, we are done with the tail and pretty much the rest of the build at this point. The only thing we got to do is make up some push rods for the tail and then the swash and stuff. But we'll do that in the next couple of steps. So yeah, everything is together. If you noticed, I'm using the stock hub shaft and the stock blade grips, and that is because I was doing some tweaking and I ended up dropping the spindle, the tail feathering shaft. I dropped it on the ground and I dented it. So I've got a new one of those on order with my next shipment. But and actually, in hindsight, that's probably a better idea. This way, this will allow me to test the stock tail blade setup, and I'll be able to put on the upgraded parts and see what difference it makes. So this will give me a good baseline to compare everything to. Overall, tail belt tension is set. It's not too tight, it's not too loose. If anything, it's a little bit on the tight side, but we'll see how it goes after the first couple of runs and see how it feels. Again, super smooth on the tail slider, virtually no effort to move it. Moves very nice. During the tweaking and the installation, though, I did need to use a ball reamer on these. I have a 4.7 millimeter ball reamer, one quick swipe, and buttery smooth. So it was just a touch tight before, but just with that one little tweak, it's good to go. Boom supports are in. Everything looks good. Everything's ready for test flights there. Next couple of steps are going to be getting all the electronics installed, and I'll cover that in the next step. But yeah, for now, that pretty much completes all the build. Everything now is up to electrical wiring and stuff, and I will show that in turn. So thanks for watching. That'll end this video. See you guys. Bye.